Okay, we want to look at a function, and that function is f of x equals 3 over x minus 2. All right, and I want to see what happens. That color's not real good, is it? Let me change the color. All right, we want to take the limit as x approaches 2 from the left of f of x, and the limit as x approaches 2 from the right of f of x. Now, this is a function that we have looked at several times, the basic function. So, as x approaches 2 from the left, what do you think is happening to the graph of that function? What happens when x is 2? Okay, x cannot be equal to 2. What would you expect to happen to the graph when x is 2? An asymptote, not a hole, an asymptote. So this looks like a variation of y equals 1 over x, which would look like this. So what do you think would happen in this function as x approaches 2 from the left? What happens to the graph? Negative infinity. Does the limit exist? No. This tells us what's happening. This is decreasing without bound. What happens if we approach 2 from the right? It goes to positive infinity. The limit does not exist, but infinity or negative infinity tell us how the limit fails to exist. In other words, it describes what's happening as x approaches 2. It's either increasing without bound or it's decreasing without bound. All right, so let's I want to give you a definition for an asymptote. We've seen asymptotes before, but here's the definition for a vertical asymptote. If f of x approaches infinity, it's a lot harder to write on this, or negative infinity, as x approaches c from the right or the left, then x equals c is a vertical asymptote. I'm trying to figure the best way to do this. Okay, if we have a function, a rational function, let's say f of x over g of x. This is my rational function, f of x over g of x. If f of c is not equal to 0, but g of c equals 0, then we end up with a vertical asymptote at x equals to c. Okay, if f of c is not equal to 0 and g of c equals 0, we have a vertical asymptote at x equals c. This requires that we get a number for the numerator. So any time that we end up with a constant over 0, we are going to have a vertical asymptote. We have f of x equals 1 over 2 times x plus 1. What is our vertical asymptote?
1.
Is it just 1? Is that a vertical asymptote? Negative 1. Is it x equals negative 1? Your answer's not correct unless you give me the equation for the vertical asymptote. Let's think about f of x equals x squared plus 1 over x squared minus 1. What can we do here?
X cannot equal 1.
Well, we know x cannot be 1. Anything else? X cannot be negative 1. I think William said it, if we factor the denominator, we get x plus 1 times x minus 1. So what are my vertical asymptotes here? X equals 1, x equals negative 1. Let's look at a trig function, because everybody loves trig functions. And I want to determine where I have vertical asymptotes. Now, hopefully you know what the cotangent looks like, but if you don't, you can always rewrite this as the cosine of x over the sine of x. Now, where is the sine of x equal to 0? At 0, at pi, where else? 2 pi. So could we say that we have a vertical asymptote when x equals n times pi, where n is an integer? So here we would have a vertical asymptote at n pi, where n is an integer. We need to be able to express answers in a form like this and understand what it's telling us. As long as n is an integer, I'm going to get a multiple of pi. Even if n is 0. 0 still can be a multiple of pi. Okay? So there are the vertical asymptotes for the cotangent of x. Does that match what we know about the graph of the cotangent? Hopefully it does.